This is Miss Steele's Precalculus class. This is part 2 of the Chapter 6 review. Another example problem is, a plane is flying in a triangular route between 3 airports. Starting at airport A, I'll make a point and label it A. The pilot flies the plane north 72 degrees east. And this distance is 295 miles. I'll label this point B. In order to reach, the heading from airport B to C is north 32 degrees west, and they are 400 miles apart. So if this distance is 400 miles to reach airport C, and they're heading at north 32 degrees west, we're trying to find the distance between airports A and C. I'm going to go ahead and connect my triangle. So I have triangle A, B, and C. It's important to know that you cannot say that angle A is 72 degrees, and you cannot say angle B is 32 degrees. I'm going to go ahead and draw in 2 dotted lines. These 2 dotted lines should be parallel to one another. They're just 2 vertical lines. So I apologize, they don't look perfect. But the angle that's made with the vertical line and the right-hand blue line that is heading to angle B is 72 degrees. And that is what north 72 east is telling us. From airport B to C, the pilot is heading north 32 degrees west. So that means from this vertical line to the route that the plane is traveling is 32 degrees. So notice that we don't know our entire angle A. Our entire angle A still has a chunk missing to the left of angle A, and we don't know any of our angle B yet. So this is when our past geometry must come into play. From geometry, we know alternate interior angles, so the 72 degree angle measure, and the angle measure that lines up with the dotted pink line and the blue triangle is 72 degrees. So now if we know from supplementary angles must add up to 180 degrees. So 180 degrees, if we subtract off 32 degrees and if we subtract off the 72 degrees, we know that this is equal to the measure of angle B. With this being said, measure of angle B is equal to 76 degrees. So we can label B as 76 degrees. Now that we have that information, we are able to solve for side length B. And B is the opposite of the angle B. Notice that we know the entire side length of A, and we know the entire side length of C, and now we know the measure of angle B. Since we now know side angle side, which tells us it's a law of cosines problem. Law of cosines, if we are trying to solve for side length B, we can say B squared is equal to A squared plus C squared minus 2 times A times C times cosine of angle B. Now all we do is substitute in the values that we know. We're still going to have B squared. Since A squared is equal to 400, we will have 400 squared plus 295 squared minus 2 times 400 times 295 times cosine of angle B, which angle B is 76 degrees. When typing this into your calculator, I would recommend just typing it in straight across as you see it. This will prevent any operator errors when it comes to remembering orders of operations and the rules of PEMDAS. This ends up equaling B squared equals 15,000 881.4. And remember, this is b squared. If you did not get this, did not get this answer, I would double check to make sure your calculator is in degree mode, and also making sure that you have completed your order of operations correctly. So since b squared equals 15,881.4, we need to solve for b. So just taking the square root of both sides, we are left with b equals 126.02 miles. And this is our final answer. And just like we have been doing in the past, I would recommend rounding to 2 decimal places. So round to the hundredths place. The next thing I want to discuss is just what's going to be on the test. So one thing to remember is converting degrees to radians and radians to degrees. You will need to do this on the test. And remember, you're either going to multiply by pi over 180, or you're going to multiply by 180 over pi. Formulas are also a huge thing to remember. So arc length formula is S equals R times theta, and the area of a sector is A equals 1/2 R squared theta, where both of the thetas in these two equations theta is in radians. So if you are given your theta in degrees, you must convert to radians before using the formulas. That was a huge mistake we saw in the quizzes that you guys have taken. Something else that will be on the test is finding reference angles. With these reference angles, you will then be asked to find exact values of trig functions, which means that you will have to use the unit circle. This is all old material that we have learned in Chapter 5, finding reference angles and exact values using the unit circle. Just instead of using a t, we're now using theta. It's nothing new, but please do not forget the unit circle. It's something that will stick with you throughout your math career. And then finally, a good way to sum it up is just to know how to solve triangles. All triangles, that includes right triangles and oblique triangles. And this is using SOHCAHTOA. We'll need to be using the law of sines, and the law of cosines. And there was examples of solving triangles using the law of sines and law of cosines in the videos today. But if you have any questions on anything that will be on the test, please bring questions tomorrow.